Hello students, let us discuss ohmic and non-ohmic conductors. The conductors that obey Ohm's law are called ohmic conductors. Ohmic conductors obey Ohm's law. That is V equal to IR. Here V is the potential difference across two ends of the conductor, I is the current flowing through the conductor, and R is the resistance. R is equal to V by I. Or we can write V is proportional to I. So current increases with increase in potential difference. So the nature of the graph is like this. Suppose V is plotted along x-axis, this is x-axis, and current I is plotted along y-axis. So the nature of the graph is that is straight line. This is straight line. So we can say conductors. So this is the VI characteristics. So VI characteristics is straight line for those conductors which obey Ohm's law. So ohmic conductors are also linear conductors. They are also linear conductors. We know that equation of a straight line passing through origin is given by y equal to mx. Here m is the slope of the straight line. So we can write Ohm's law in form of y equal to mx. So I is equal to 1 by r into v. Here this y is I and x is v, and slope m is, that is 1 by r. So here slope of the straight line is, that is 1 by r. So 1 by r is slope. So resistance can be written as r is equal to a reciprocal of slope. Now we take a typical example. Consider two metals. We consider two metals. Metallic wire obey Ohm's law. So metals are the ohmic conductors, like aluminum wire, copper wire, silver wire. Aluminum, copper, silver, these are ohmic conductors. Now we consider two metals. Now we plot the let us plot two characteristics. V is plotted along here x-axis and I is plotted along y-axis. So this is for metal 1, and we draw another characteristics, VI characteristics, that is this is metal 2. Now question arises, which metal have more resistance? So let us find the slope. So for the metal 1, slope is S1, and for metal 2 slope is S2. So S1, suppose this angle is theta 1 and this angle is theta 2. So here theta 1 is greater than theta 2, or we write tan theta is greater than tan theta 2. Slope is m equal to tan theta. Slope m1 is greater than m2. That is slope, or we write slope S1 is greater than S2. We know that slope is equal to 1 by r. So 1 by r1 is greater than 1 by r2. So this implies r2 is greater than r1. So resistance of metal 2 is greater than resistance of metal 1. Next, let us discuss non-ohmic conductors. The conductors which do not obey Ohm's law, are non-ohmic conductors. Ohm's law is V equal to IR. So here, if we increase, suppose we increase V, then here R is not constant. In case of non-conductors, this R varies. R varies. Similarly, if R varies, I also varies. So this also varies. So for non-ohmic conductors, all three V, I and R varies. But in case of ohmic conductors, only V and I vary, but R remains constant. So let us show graphically. Now V is plotted along x-axis and I is plotted along y-axis. Suppose this is the nature of the graph for non-ohmic conductors. The examples of non-ohmic conductors are junction diode, electronic valve, etc. So now from the VI characteristics, we take 2 points here. Suppose this is a point 1 and this is point 2. Now we draw the tangent here. We draw the tangent at point 1 and slope is suppose S1, and draw another tangent at 2. Its slope is S2. So from the figure, S1 is greater than S2. Slope at 1 is greater than slope at 2. That means S1 is greater than S2. And we know the slope S equal to 1 by R. Slope equal to 1 by R. So 1 by R1 is greater than 1 by R2, or R2 is greater than R1. So resistance at 2 is greater than resistance at 1. So resistance varies in case of non-ohmic conductors. So this is about ohmic and non-ohmic conductors. Thank you.